Hello, in this video we are going to be looking at how to differentiate sin x and cos x from first principles. So let's start by reminding ourselves how we differentiate from first principles. Imagine that we've got a curve and we choose 2 points on the curve and we work out the gradient of the line segment between them. So we've got y equals f of x, so the bottom left point we're calling that x and f of x, and then if we add a little bit to x we can call that x plus h. And similarly y will be f of x plus h. So the gradient of that line segment will be the change in y over the change in x. That's f of x plus h minus f of x over x plus h minus x, which will simplify just to h. And the smaller the difference, the smaller the value of h, the closer the gradient of that line segment will become to the gradient of the tangent at that point. Now, in order to use first principles for sin x and cos x, we are going to have to use the compound angle formulae or additional angle formulae from trigonometry, the ones that say sine of a plus b and cos of a plus b. So as you can see, sine of a plus b is sine a cos b plus sine b cos a, and cos of a plus b is cos a cos b minus sine a sine b. And one other thing that you will have learnt in trigonometry, the small angle approximations. So for small values of h, sine h in radianses is approximately equal to h, and cos of h is approximately equal to 1. So when we have y equals sine x, we have sine of x plus h minus sine x on top. That's your f of x plus h minus your f of x. And we have our x plus h minus x on the denominator, which of course is just h. So using our compound angle formula for sine of a plus b, sine of x plus h becomes sine x cos h plus sine h cos x. And then we can use our small angle approximations. So cos h is approximately equal to 1 and sine h is approximately equal to h. So on the numerator we have sine x times 1 and minus sine x, which cancel out. That leaves us with h cos x over h, so the h's cancel out, so we end up with cos x. So if y equals sine x, then dy by dx is equal to cos x. We can do exactly the same thing for cos x. So f of x plus h would be cos x plus h. We'll have minus cos x all divided by 8. So cos a plus b is cos a cos b minus sine a sine b. So here we'll have cos of x plus h is equal to cos x cos h minus sine x sine h. And again, using our small angle approximations, cos h is roughly 1, sine h is roughly h. So we can replace them with those. And this time we have cos x times 1 minus cos x, which cancels out, leaving us with minus sine x times h over h. The h's cancel out, and we're left with minus sine x. So if y equals cos x, then dy by dx is equal to minus sine x. Okay, we're now going to have a look at what happens if we have things like y equals sine 3x or cos 3x. So if we replace the x with x plus h, we get sine 3 lots of x plus h. Before we apply the compound angle formula, I'm just going to rewrite that as sine of 3x plus 3h. So again, we know that sine of a plus b is sine a cos b plus sine b cos a. So sine of 3x plus 3h is the same as sine 3x cos 3h plus sine 3h cos 3x. So again, cos 3h is still going to be roughly equal to 1, whereas sine 3h is going to be roughly equal to 3h. So we've got sine 3x times 1 minus sine 3x, which is 0. And we've got 3h cos 3x over h, so the h is cancelled out, but we're left with 3 cos 3x. So if y equals sine 3x, then dy by dx equals 3 cos 3x. So in summary, and bear in mind these apply when k equals 1 as well, for sine x and cos x. If f of x is equal to sine kx, then f dash x is equal to k cos kx, like we saw with our sine 3x giving us 3 cos 3x. And although we haven't had a go at this, if we have f of x equals cos kx, then f dash x will equal minus k sine kx, in the same way that cos x gives us minus sine x. And when we differentiate sine, we get cos. When we differentiate cos, we get minus sine. If we carry that round, differentiating minus sine will give us minus cos, and differentiating minus cos will give us sine. So we can put those results in a circle, the circle of trigonometric differentiation, as shown.